Hello everyone, welcome back to our channel Geomatics Engineering. Here we learn and explore the things related to geomatics engineering. So, starting with today's lecture, today we are going to see remote sensing process. So let's start. Here it is a schematic diagram of remote sensing process, how it occur. First, here written that energy source comes in the form of electromagnetic radiation, then interaction with atmosphere takes place, and then interaction with target takes place, then recording of energy happens, then transmission, reception and processing happen, then interpretation and analysis happen, and then at last we use that information for various applications. So we will see each step one by one in deep. So starting with energy source. We have already seen that in remote sensing, energy travels in the form of electromagnetic radiation. We have learned about electromagnetic radiation in previous videos. So there are various sources of electromagnetic radiation. For example, sun. Sun itself is a bunch itself produces bunch of electromagnetic radiation and send it towards earth, and then reflected energy get sensed by the satellite or aircraft. And then there are some sensors which itself capable of sending electromagnetic rays toward earth, and then reflected rays recorded by them. There are also some sensors which records emitted rays from the earth surface. So emitted rays from the earth surface also a source of energy. So here we are seeing three sources of energy: sun, active sensor, and earth surface itself source of energy. Next, moving on to interaction with atmosphere. Once electromagnetic radiation travels through space, then it does not get affected or modified, but once it enters in the atmosphere, it gets modified because of dust particles and gases in the atmosphere. So once it enters in the atmosphere, four types of interaction with atmosphere happens: absorption, scattering, refraction, reflection. All these four happen when electromagnetic radiation enters in the atmosphere. So starting with absorption, absorption of electromagnetic radiation happens either partially or fully depending upon the wavelength of radiation. Also depending upon what type of pollutant or particles are available in the atmosphere. Main constituent which are responsible for absorption of electromagnetic radiation are ozone, carbon dioxide, water vapor. These constituent narrows down the bands which are available for remote sensing. Means we because of these type of particles and constituents, we are not able to get the full electromagnetic radiation to the target. Only some amount of electromagnetic radiation from sun, or we can say space, are able to reach the target. So for example, ozone absorbs UV rays. It is helpful for us because UV rays burns our screen. So ozone itself protect us from UV rays by absorbing it. Carbon dioxide. Carbon dioxide work as a greenhouse gas. It absorbs thermal infrared rays. Thermal infrared rays. Water vapor. Water vapor absorbs near infrared and near microwave and far infrared rays. And water vapor depends upon the space and depends upon the location. Constituent of water vapor varies. So absorption of water vapor uh, radiation of absorption due to water vapor varies from place to place. So these are the absorption. After absorption, the remaining bands which are not being absorbed by these pollutants, or we can say constituents, are able to reach the target. So these remaining bands which having less absorption are termed as atmospheric windows. Means remaining range of wavelengths, for example we can see here, this range of wavelength is not being absorbed, it is able to reach the target. So these type of ranges are known as atmospheric windows. So we can define atmospheric windows that remaining range of wavelengths that are able to reach the target are known as atmospheric windows. And our remote sensing sensors are designed for these atmospheric windows only. In this figure we can see this visible light rays, infrared rays having less absorptivity. Also this microwave is negligible absorption happens here. Hence microwave is very good for remote sensing. Next, moving on to scattering. When electromagnetic radiation gets contact with atmospheric particles, for example here we can see that these are the some gaseous particles or pollutants. When incident rays get contact with it, then it get deviated in several directions. But these are not able to go down, some amount of it get dispersed and deviated in all other directions. So this is called scattering. The dispersion, or we can say diffusion of incident ray in other direction is known as scattering. And scattering depends upon two things: wavelength of radiation and size of particles of atmosphere. Means these particles at size and wavelength of radiation, these two affect atmospheric scattering. Also, amount of scattering is inversely proportional to fourth power of wavelength. Inversely proportional to fourth power of wavelength. That means longer wavelength will have less scattering and shorter wavelength will have more scattering. So this is about scattering. Now we are moving towards refraction. Here pay attention because from refraction quite good amount of things can come in exams. First of all, let's see what refraction is. We have seen absorption, that some bands get absorbed in particles. We have seen scattering because of particles and constituent bands get diffused. Now refraction. When rays moves from one medium to another, means one medium means this whole place having some other density, some other medium, for example air and water. So when electromagnetic radiation travels from one medium to another medium, then deviation occur. Means for example if you are saying that this ray is incident or over this, then it should go like this, but some deviation will occur and it will bend. This bending of radiation is known as refraction. And here velocity of electromagnetic radiation also changes. Velocity of electromagnetic radiation in vacuum is speed of light, but in different mediums its velocity changes, which is expressed in form of index of refraction. Here index of refraction is defined as ratio of velocity of light in vacuum, means we can say VC, vacuum, to velocity of light in that medium, VM. So this is called index of refraction. Also, for refraction, Snell's have given a law which is defined as product of index of refraction with product of sine of theta. This theta is incident ray with normal of that plane. Sine of theta remains same. So from this we are able to find what angle, what deviation angle will made by the ray in different medium. So this is given by Snell law. Here we can write down for these two medium 1 and medium 2, that n1 into sine theta 1 is equal to n2 into sine theta 2. Also from this law we can say that more dense medium, then bending will occur towards the normal. Less dense medium, then bending will occur away from the normal. So this is about refraction. After refraction, last thing that remains in interaction with the atmosphere is reflection. In reflection, quite good amount of radiation bounces back from clouds, no? And due to this, image become hazy and clouds appearance occur in the image. For example, you can see here, this is a image, satellite image, and here good amount of cloud occur. So we are not able to process this. So this type of thing happen in reflection. It decreases the quality of image. So this is all about interaction with atmosphere. After this interaction with target, the radiation which is not get absorbed or scattered, that reaches to the surface, and there three types of interaction occurs, that is absorption, transmission and reflection. When it comes to target, radiation is talked in terms of radiant flux. What is radiant flux? Radiant flux is a rate of change of radiant energy per unit time. So from here I will talk in terms of radiant flux. The incoming radiant flux over an area or target is known as irradiance. The outgoing radiant flux is known as existence. This is just a term you should keep in mind. And also this reflected, absorbed, transmitted, it can be represented by simple energy budget equation, which is written that phi incident is equal to phi reflected plus phi absorbed plus phi transmitted. Here I want to tell something, that the reflected, absorbed, transmitted over some surface or some target when an incident ray comes. So we will talk about hemispherical surface for around this patch of land of object or anything. So we will talk about hemispherical surface around this, not whole sphere, only hemispherical surface, because rays will reflected from this like this in the form of hemisphere. So in remote sensing, only this hemispherical surface is important to us, not the whole spherical surface. Hence we are writing here that these all are radiant energy on surface from any angle in hemisphere. Hence we use hemispherical absorption, reflectance and transmittance in remote sensing. So one by one we will see each of them. Hemispherical absorption, it is represented by alpha. It is ratio of phi absorbed to phi incident. Then hemispherical reflectance, it is represented by rho. It is ratio of phi reflectance to phi incident. Then it comes hemispherical transmittance. It is represented by tau. Same, phi transmitted to phi incident. So these all are variable which we can use for calculation of incident radiant flux and reflected radiant flux. Out of all these, that is reflected, absorbed and transmitted radiation, our importance is given to reflection when it comes to remote sensing, because reflected and radiant flux from target reaches the sensor. So our importance or our attention is given to reflection only. Here, reflection depends upon two things: wavelength of energy and surface of the target material. And depending upon these two types of reflection happens: specular and diffuse. So we will see them. For example, when a surface is rough, means undulation is more with respect to wavelength, and wavelength is small. Then wavelength will come incident over the surface and get diffused in many directions. This is called diffuse reflection. But when surface is quite planar with respect to wavelength, means either wavelength is large or surface undulation is less, very few, then incident ray will come and most part of the incident ray will deflect in one direction only, and other direction will get very few or nominal, negligible. So this is called specular deflection. And roughness of surface is defined by Rayleigh's law, or we can say Rayleigh's expression, that if we will count this as an average height h, surface undulation average height h, and wavelength of ray is lambda, then if h is less than lambda by 8 into cos theta, where theta is the incident angle, then surface is called smooth, otherwise surface is called rough. So for smooth surface, specular reflection occur, and for rough surface, diffuse reflection occur. Next we will see four types of nature of specular and diffuse reflection, that is perfect specular reflector, near perfect specular reflector. Here all the incident ray get deflected in only one direction. Here some of the incident ray that get deflected in other direction, but maximum part of it get deflected in one direction only. So it is near perfect specular reflector. In diffuse reflector, near perfect, mostly in all direction reflection occur, but some direction get more and some direction get less. And in perfect diffuse reflector, almost all direction get same amount of reflection, and perfect diffuse reflector is known as Lambertian surface. So pause the video here and think that for us, for the application of remote sensing and for the process of remote sensing, out of these four, which reflection, or we can say out of specular and diffuse reflection, which one is suited for remote sensing process? Pause this video and think about it for a minute. So answer for this is diffuse reflection, because if we take specular reflection, then reflection will take place only in one direction. So we require that sensor should available at this site during the recording, otherwise recording will not happen. So sensor position need to be fixed. So it is not necessary that sensor will be available all at the time of reflection here. But in diffuse reflection, you can see in every direction amount some portion of almost in perfect diffuse reflection equal portion of reflection happens in every direction. But we are getting some amount of reflection in each and every direction. So sensor position, whatever the sensor position at the time of reflection, doesn't matter, it will get some amount of reflection at that time. So diffuse reflection is good for remote sensing process. For different type of land features, different type of spectral reflectance occur. For that, if you want to see, go in the Telegram channel, link in the description, and see there various type of reflectance occur for various type of feature. Next, we are moving to recording of energy by sensor. So we have seen that uh, energy first interacted with the atmosphere, then interacted with the target, and that then reflected radiance from the target comes to the sensor. But is that only the from the target energy is being recorded? No, not only from the target, but also from the adjacent object, and also some amount of scattered or reflected energy from the atmosphere get recorded by the sensor. So the reflectance radiance recorded by sensor is not only the target radiance only. It is a combination of radiance reflected by target alone along with the radiance reflected by adjacent object, and some radiance is from atmospheric scattering and reflection. So the atmospheric scattering and reflection and adjacent object both termed as path radiance, because these are not desirable unwanted radiance and they arrive with the target radiance also. These are called path radiance. So total radiance that is recorded by the sensor, let's assume it LS, it will come as combination of target radiance LT plus LP path radiance. So this is for recording of energy by sensor. Next, we are moving towards transmission, reception and processing. Transmission, reception and processing can be understood as when raw data received by satellite, it contains some amount of error and discrepancies which needs to be corrected. So these data were transmitted to the ground receiving stations, and several corrections occurred over that. For example, geometric correction, radiometric correction, and then these data are converted into another form and get saved in another type of disk and CDs. So these all things happen in transmission, reception, processing. We will see corrections in further classes. Next, moving to interpretation and analysis. For daily use man, raw data is not these men cannot read raw data. So interpretation and analysis is required to make these data more informative and for production of meaningful information. So there are a variety of image interpretation and processing techniques, out of which visual image interpretation and digital image interpretation is one of them. We will see in further videos about them. At last, application. We have already seen that remote sensing had wide range of application, out of which some are written here like soil health monitoring, natural resource observation, medical crisis analysis, navigation and transportation. Various applications are there for remote analysis. So that's all for today's video. Thank you for watching. If you haven't subscribed our channel till now, then subscribe it and also join our Telegram group, link in the description. Thank you for watching.